Okay, hello everyone. My name is Jad Al-Haber. To tell you a bit about myself, I'm basically a digital forensics and incident response consultant. I've been in the field for almost 5 years now. And this channel is going to be about mainly CyberDefenders, Hack the Box, Try Hack Me challenges, walkthrough basically. It's gonna be for all levels. Beginners, professional, people that are trying to move from SOC into digital forensics. Basically, anybody can take something from the videos that I'm gonna be introducing. So for this video, I'm gonna be doing a walkthrough basically of WorkFromHome lab. And basically it's a medium level lab, and the main topic about this is to basically analyze Windows file system artifacts, and we're gonna check basically the scenario, and we're gonna be going step by step through all the questions. I want you to understand that this channel is mainly me doing everything from scratch with you guys in here and trying to figure out things as we go, and hopefully you will like this content, guys. Okay, so I went ahead and I already opened like the challenge, and I've launched it, and basically here we have the actual lab. So let's check the scenario while it's loading. So basically there is a Zero Divine Security Operations Center, detected a sudden spike of outbound remote access traffic and privileged logons originating from a single Windows 10 workstation in the development network. The timing matched a peculiar internal chat in which a junior developer repeatedly asked a senior colleague for elevated credentials, prompting the SOC to quarantine the host and capture a full forensic image for review. As part of the Zero Divines unit's DFIR team, you now possess that image, the complete senior-junior chat transcript, and concise IT meeting notes collected during the response. Your mission is to reconstruct the sequence of events, determine any data or credential exposure, and distill actionable remediation and hardening recommendation for leadership. So it's simple. Basically, we have two developers in here, one senior, one junior, and it seemed that the junior messed up somehow, and basically now you have a operating system that is, like sending a beacon to a C2. So first, if you're unfamiliar with CyberDefenders, so you usually have to go and start here, and basically you have the artifact and you have the tools. The artifacts basically contain the actual triage image in this case, that basically contain all the files that were collected from the machine, and sometimes they do add a bit of context to the actual incident. So let's go. Apparently in here we have two files. We have a meeting summary. Let's open it and see what's inside. So basically here, if I'm looking quickly, the workstation under review is the only host with RDP enabled in the environment. Two users are bound to this machine. So basically two users use this machine. You have a junior that logs in locally. So basically the junior are not supposed to be RDPing or connecting remotely to this machine. And we have the senior developer that usually connects remotely via RDP for provisioning tasks and hold permission to take ownership of the junior file. So the senior developer can basically take permission and ownership over the junior's file. So, and here the junior reportedly said that someone claiming to be the CTO requested urgent access to an internal website. So basically he installed a remote access software. And then the senior also contacted through the junior's account, briefly confirmed with the junior, and basically supplied administrative credentials to the junior. However, the CTO came later and he said that basically he didn't do such requests. And basically tell you that we have the cape triage of the workstation. And they also gave us basically a suspicious chat that happened between, I guess, the junior and the senior. So let's open the chat, and you can see basically Donald Chalala saying that he has an urgent task. And basically Donald tells John that the CTO reached out to him and he wants like his credential. And eventually, as you can see, he gives him here the credentials. So now we need to see what the questions are about, and we can move on in the questions. So let's start with the first question. The threat actor tricked a junior into installing remote desktop software. What is the start download timestamp of the software in UTC? So when I look at this question, usually my first instinct is if you are downloading or installing something, normally you would use a browser. So first I want to check what kind of browser we have in the image. And depending on that, we can move forward. So I'm gonna go to the artifacts, close this, I'm gonna go to C, users. Since we're looking into this, because the junior was strict, so we have to go into the junior's profile, so it's gonna be Donald T. And mostly all the time, browsers data are stored in the app data folder, local, and you will have basically here a list of different providers and like actual companies. In this case, we have Microsoft. So if I'm assuming if there is Edge inside, then basically there's like Edge browser artifacts. So like we said, there is Edge, user data, default. Default is a default profile that is like, if you can create multiple profile in Edge, since it's like a Chromium based browser. In this case, since there's only one, then this means there's like a default. And here you can see all the files that are related to basically like browser artifacts. And you can see like history, you can see bookmarks, you can see top sites, shortcuts, preferences, and so on. So to actually have access to the history, like basically the history of downloads using the browser, we have to use a SQLite DB browser, because the history file that we saw earlier, it's an SQLite database. So let's go. You go to the tools, miscellaneous, and you have here the DB browser SQLite. We open that program. Okay. One thing that I dislike, it's because this is running in the cloud, so it's not really based on how fast is your machine, so you have to just like sometimes just wait for it. So we are waiting for it to work. Okay, open multiple instances. All right, so we go again, we open a database, and we go all the way to desktop, start here, artifacts. We go all the way to the same path, users, Donald T, app data, local, Microsoft, Edge, user data, default. So you come to the path, but you don't see them. Why? Because those files don't have really extensions. So you have to click on all files, and here they are. So let's go to the history and let's check. So you can see here basically all the tables, and you are really interested in this case in the downloads table. So let's go to the downloads table and see what's inside. And let's check again. So what is the start download timestamp of the remote desktop software that got installed? So let's check basically what got installed. So you can see here basically what got downloaded. You can see that it's AnyDesk. It got downloaded from AnyDesk. And you can also see here that sometimes it just doesn't render for some reason. So you can see it in here, and you can see basically that AnyDesk was actually downloaded and installed. To know the timestamp of when it was downloaded, we have to check the, I would assume, the end time. However, in the database, it's in the WebKit timestamp, and we want to translate that to actually human readable. So I'm gonna do WebKit to timestamp converter, and we're gonna basically try to check. And as you can see here, the timestamp in UTC is the following. Actually, sorry, this one. So it's Saturday, June 21st, 2025, 9:02. So let's try to put it in here. So it was 2025 June, so it's 07, and then day was what? It was 21, and then 9:02, so 09:02. And okay, let's try this one. Actually, maybe it could be the start. Let's go back. Interesting. Sorry, it's 06, my bad, because it's June, not July. And here we go. So let's continue the second question. Now it says, by tracing the incoming session request in the remote access tool, what is the profile name of the threat actor on the remote access tool? I want you to be, guys, very careful on the way they ask the questions in CyberDefenders. They say trace incoming session requests. So basically that's what we want to be looking for related to the remote access tool. So that means there's application data related to AnyDesk, and inside of that information, we're gonna see incoming session requests. And based on those events, we're gonna see basically the profile name. So based on that, we're gonna go and check basically how we're gonna figure this out. So since we said that app data and the user profile is where it holds the data for the actual application, so we're gonna go ahead and go again to the juniors Donald T app data. I already know where AnyDesk application data exists, so it's in the roaming, and you see here AnyDesk. So now here we have all the data related to AnyDesk. And basically you can see here, for some reason, it's saying that add.trace is a Wireshark capture. However, it's more of a text file. So we can technically open it using Notepad. And this contains a lot about sessions, about everything that technically happened on AnyDesk. So since they talked about, like we said, incoming session request, we're gonna search for that. So we're gonna put incoming session request, and we're gonna do find all in current document. And here we go. As you can see here, we have one hit, and if you look at the line, it's at 9:03. So it's immediately after it got downloaded, we have this incoming session request with a profile called 0CTO. So the threat actor created a profile called 0CTO because the company name is 0 something. And so he's trying to be sneaky about it. So let's add this to see if it's correct. And it is indeed correct. So let's move forward and talk about discovery. So the attacker appears to have discovered an internal website via browser bookmarks. What is the URL of this internal site? So again, we are saying here that inside of the browser bookmark, there is like an internal website that got saved. So we're gonna go to the app data of the Edge browser for that Genius developer, and we're gonna check what are the bookmarks that got saved. Now, unlike history, it's not in unlike history bookmarks, as you can see here, it's technically not an SQL database. It's just a JSON file. So you can do the same with edit, and you're gonna have basically, as you can see here, the data. And it's basically very easy in this case. You have the bookmark bar, and inside you have basically when it got added, you have basically the name, so 0 divine unit web. You have basically source, how it got added. It's basically it got added by a user, and it's a URL, and how many visit count you have. One, so one time it got visited using this feature. There's nothing else in here that is related to URL. The only URL exists as 0divine.u.com. So most probably this is the answer. So let's take that and check it out. All right. I think it's correct. So let's move on. Question 4. After the threat actor obtained credential from a senior developer via social engineering, what timestamp marked their access to the internal website? So as we can see here, we have to figure out now when did the attacker actually access that website. And to do so, we have to think what gives us basically the idea about accessing. So let's first figure out what options do we have, right? And just give me a second. Wait, access. Okay. So access here, I don't think they mean by authentication. They mean more about when he actually went to the website itself. So in this case, he probably went through the browser. So again, we are still in the browser territory in here. So I think we have to reopen the DB browser SQLite. Sorry, guys. So let me do it again. So it's gonna be in the tools. It's gonna be in the miscellaneous. Gonna be in here. And let's open the database. And basically we're gonna go to the same path as before. Donald T, app data, local, Microsoft Edge, user data, default, and all files. And we're gonna go back into history. Another table in history that's interesting is the URLs. So basically this is basically everything related on all the URLs. Basically it's your history file, everything that you visited. And as you can see here, we have a 0 divine URL. Basically it's a subdomain of what you found earlier. And we have the last time visit in here. In this case, it's the first time as well because the visit count is 1. So let's take that timestamp, do again the same thing we did earlier, and check. So you can see it's 9:10. So let's try to put that into the, sorry, in here. So it's gonna be 2025, sorry, dash 06 21 9 10. And here we go. We're good to go. And one last thing, the threat actor downloaded multiple files from the internal site, including a PDF. What is the size of that PDF in kilobyte, integer value only? So let's check in the history as well. Like we mentioned before, this is downloads. And let's check basically what he downloaded from that website. So we have 4 files. And one of them is an actual PDF. So let's go check basically this one. So let's check this one. It's actually number 3. So let's check the total bytes, and the total bytes is actually this value. We can do a simple divided by 24, and we're gonna have a 662. So I'm hoping they didn't round it like up, but it could be the case. Let's check. Okay, it just works. Now let's continue into exfiltration. So when the threat actor began transferring the downloaded files back to their system via the remote access tool. So now I have to go back to the actual, like AnyDesk app data, and we're gonna check the. I believe there is a specific files. Let's go back to see. It's in here, and we have something called file transfer trace. Just like in the name, it should basically show you when everything happened. So again, he accessed the website at 9:10, and as you can see here, guys, at 9:12 he started transferring a file, and you can see he's uploading it back. So he's uploading it, so it means it's back to the attacker, and he's uploading basically annual business plan. So let's go ahead and actually put the answer in here. So it's 2025. Wait, sorry, let me copy it. It would be easier for me. So, and then 0912. All right, credential access. Question 7. It seems like the attacker identified a pattern in the internal website's password, and basically start applying it to the senior developer account. What IP address was used to brute force that account? As mentioned in the beginning, I believe that this user can RDP into this machine. So we have to check, in this case, the event logs. I like to always use Cape to parse my data. It's just efficient for me. If you guys want to just use the EVTX ECMD by Eric Zimmerman, you can do it on your own, but it's basically the same thing. So I'm gonna go ahead, tools, miscellaneous, and Cape. I'm gonna use Cape. It's a bit of an overkill to use Cape in here. It just, for me, it's easier to do so. So let's wait to load. In the meantime, my thought process is to, since we're checking the event logs and want to check a brute force, we have to probably check the event code 4625. If you guys are not familiar with what 4625 event does, it's basically record the login failures that happen on that device. So now we're gonna use Cape. Module option is basically the option where you can run different programs on your already collected evidence. So in this case, my source is gonna be where the artifacts are at, and they exist all within this folder. Module destination is basically where I want the result of the tools that I'm gonna be running against those artifacts. I want them to be stored. In this case, let's make it easy. Let's store them in the start here folder. And we're gonna remove flush because flush basically removes everything else in that folder, and we don't want to do that. So be careful. And let me use, as I mentioned, EVTX ECMD. You can use the RDP because it's gonna process only the RDP events. However, for me, I want everything in case in the other question I might have to use other type of events other than only RDP ones. So we're gonna just click execute in here, and now we wait. So while we're waiting, again, like I mentioned, so basically we have to look into 4625. We look at the all attempts that has been done on the senior developer account, which is in this case, I think, John. And based on that, we can tell the source, and hopefully we can have basically an idea of what is the IP. So let's wait a bit. Probably in the video I will try to cut it a bit or like make it a bit faster for you guys. All right, it's done. And let's go to start here. And we have the event log that are here. So I like to use Timeline Explorer to analyze CSV files, which is also made by Eric Zimmerman. So let's go to the tools and let's go to the log analysis and let's go to Timeline Explorer. Let's wait for it to load. Okay, it's taking some time. Sorry guys. I'm gonna make sure in the video actually like I make it short or like skip those parts where we are waiting. Okay, it's open. So file open and let's go to the start here, event logs. And let's look at the actual content. All right. So as mentioned before, we need to look into the 4625 event, which basically show us, like I mentioned, that will show us all the login failures, basically. And you can see here failed logins. And then you want to look at one thing. One thing you have to want to look about is payload data 1, which basically is a target user that is trying to authenticate. In this case, we have John K, right? And for some reason, there's a Kali here, which is definitely suspicious. However, as you can see here, it's all log on type 3. And the reason being why it's not, because usually log on type 10 is the one related to RDP. So the way RDP works in some environment, there is something called network level authentication. So first, it will authenticate on login type 3, and then afterward you will have the login type 10. But since the level 3 is already failing, so we only get the login type 3 in this case. So, and you can see here the failure reason. This caused either a bad username, authentication, whatever. And anyway, for this is the IP for the question. So let's take that and make it easier for you guys. Great, so it's correct. Now let's see the actual second question 8. It appears that the attacker obtained the correct password of a senior developer and logged into the workstation via RDP. When does the login occur? So now to check the login that are successful, we have to use 4624 instead of 4625. And also we want to check usernames that are related to whom? John K, I guess. John, let's put John in here. Okay, no. Let's remove that. And let's see. So maybe here, sorry, my bad. John, maybe. Let's try. Oh, we have that. So we have here the same remote host, and you can see the remote host is called Kali. And maybe if you see the timestamps, let's make it sure. So you can see it started with Kali, and then we have 0B. So I don't really know what happened in here, but all I know is that basically he accessed around that time. And we are asking here basically for when did this login happen, and we're gonna look at the login type. So I want the login type 10 because it's basically when the RTP, we have the network level authentication, and then here is basically when the actual interface when your RDP happens. So let's take that one. So it's gonna be 915. So again, let's copy paste it like that. And here we go, it's 915. So let's continue. And now privilege escalation. It seemed like the threat actor leveraged a well-known LOL bin for special privilege discovery by correlating its execution timestamp with other privilege-related events. What is this privilege? So now they're asking about the privilege of the account that he was logging in, which in this case, John. And if you don't know about Windows, I think there is a specific event regarding administrative logins that usually shows the logins and basically all the privileges. So in this case, I think the event is called 4672. So let's try to look on that, and let's clear everything first. 4672. 4672. And let's check what we have here. You see here, this is the list of privileges for each user in this case. So system, those are the privilege. And we are looking for the privilege of John, right? So let's try to see if we have a John in here somehow. We do. So let's click on that. And as if you remember, guys, in the actual scenarios, they said that John can take ownership. And this is the name of the privilege. It's called SE Take Ownership Privilege. So let's put it in here. It's correct. What two LOL bins were utilized to take advantage of the privilege identified in the previous question? So now we want to figure out what are the LOL bins. If you're not familiar with what LOL bins means, it means living of the land binaries. Those are basically Windows binaries that are actually how to say that, like exploited because it can be used for malicious activity, or basically like Windows or any kind of EDR will not trigger on them because they technically are Windows executables that are signed by Windows. So usually threat actors take advantage of those LOL bins to do something that they shouldn't be doing. So now to look again at the question, they want us to know which LOL bins took advantage of this privilege. So to know which processes ran on this system, there are multiple artifacts. However, the most basic one is called Prefetch. So we're gonna start with a Prefetch and we're gonna do the same thing. So instead of evtx.cmd, we're gonna do pecmd, which is another tool by Eric Zimmerman that will process Prefetch files. So we're gonna do the same thing, and now we're gonna click on execute, and we're gonna wait. We're gonna wait until it processes. And as I mentioned, I will be cutting everything related to waiting. Okay, it's done. So again, we're gonna have another CSV file that we're gonna look at, and it's gonna be program execution, and you have two files. One is related to the timeline, which I'm more interested in this case because I want to know what happened immediately after he logged in. So let's go and check. Let's do a sorting based on timestamps, and let's check let me check again what was it was 9:15. So let's check what happened after 9:15. If you guys are unfamiliar with basically Prefetch, so Prefetch is basically like a I don't want to call it cache mechanism, but basically it's a feature in Windows where it will allow programs to run faster in the future. So basically it collects, whenever you run a program, it will collect basically the first 10 seconds data that gets loaded in the memory. So the next time you run it, it runs faster and more efficiently. So let's check in here what happened around 9:15. So you can see here that we have, for example, SMSS, login UI, when log on, search protocol host, DLL host, SVC host, onreg and p2.exe, and we have ie4unit.exe. And if you guys are not unfamiliar with those, to be honest, I'm unfamiliar with them myself as well. So let me throw a small Google search on those. It's basically, it's a executable that it's developed for media player. And let's check the other one, the i4 unit. Let's check, because you know Windows have a lot of executable and you're not gonna be memorizing every single one. Is the Internet Explorer per user initialization utility. All right, interesting. So let's go back. To be honest, when I look at that, I don't think those are the executables. So let's look more into what other executables and on there. So I like to take a quick, oh, all right, can see it already. cmd.exe, this is already something suspicious. So first, usually they always do who am I for some reason, attackers. It's like something very like seen, is to check basically what privileges they have on that CMD. And you can see basically here that all the john.k app data, because now it's logged in. And you can see two things. You have iCalcs and you have take own. Take own is in the name, take ownership of a file. And iCalcs, if I'm not mistaken, let me double check. It's basically related to backups. And basically you have to know that attackers target backups because there's a lot of information there. And it's also related to ACLs. So I think those are gonna be the actual answers. So let's check. I believe take own is gonna be first, take own exe, and then the other will be iCalcs exe. Sorry, iCalcs. Wait, I see ACLs. So I see ACLs. Right. For some reason it's not working. So let's try again. Take own.exe, comma, and then I see ACLs.exe. And it works. I don't know what happened the first time. Okay, guys, this is gonna be a continuation of the first part. So I'm sorry, I had to take a break. So again, here we have the question 11. So let's go back to that. Which executable was the first target of these two logins, and who was the original user with the full control of that file? So let's first think a bit about what we know so far. And basically what we know is that we have the two executable that are taking advantage of the SE take ownership privilege. And the take on and the icacls.exe, which basically modify the ownership and basically like who owns and the permissions of the files. We have to check around the time of execution if any files in the file system had their ownership changed. And there is only one place and one artifact that gives us this information, and it's called USN Journal. So we're gonna use mft.exe to do that for us, because that's the entire purpose of having, you know, like those tools to help us do our job faster. So we're gonna go to process $J and we're gonna execute it, and we're gonna wait for it to finish executing. And in the meantime, I'm gonna explain my thought process. So as I mentioned before, so the UNS journal keep track of all the files and is gonna basically give us everything that happened to the files in the file system. So for example, if there is a file creation, it will record it. If there's file deletion, it will record it. Rename, it will record it. In this case, if there was like a security change, ownership change, it will even record it. So in our case, since there is an ownership takeover, so the security of the file has changed, that the file that we're kind of that we're gonna basically track. And as you can see here, we have the $J, and we're gonna go with the timeline explorer and basically go to open the file. Let it load. It's gonna take a bit because it can be heavy. So we open the file. Okay. And as you can see, we have timestamp, we have name of files, extension, entity, everything. And here we have the update reason why this USN journal was updated. And like I said, I want to look for a security change. So let's try to filter on that. So let's open that. Let's put security change. Okay, maybe I would want to put it there and make it easier for myself. Okay. So now my goal is to also filter on the timestamp, because here we can see a lot of 2020 June, and technically everything happened after 21 June. So let's go there as well. And we're gonna go to 2025, June 21st, click OK. And now what we're gonna do is we wanna check around the time that the user connected, which was, if I remember properly, it was 9:15. So let's try to go a bit down. And actually, we want to look around 9:18 because that's when technically the ICACLs and take on 9:18, 9:19. That's probably gonna be like our best bet in this case. So we are here. You can see it, 9:19, 9:18. It's here. And usually, if you want to manipulate something, you would want to manipulate something that's actually interesting for you, right? And in this case, we see something that is I feel like the only thing of interest in here. And the only executable that we see in here is this sethc.exe. And this specific executable, if you do a small Google search, is relating to the sticky key. So it's like when you guys click like shift 5 times, basically, and you get like this pop-up, you know, like sticky key, do you want to enable sticky key? It's basically this executable that's getting executed. So I guess if we look at the pattern here and it's actually match. Now the other thing is to basically check who's the owner of this, you know, like who's the owner of this file. So let's try to figure that out. So my one thing that I would like to do is that it's like you don't have to be kind of afraid of using like Google or any other like awesome tool for you to get an answer. Like not all the answers are gonna come easily in the lab. Sometimes you have to kind of even cheat your way into it. And usually, since this SETHC executable exists in the C Windows System 32, if you do a small Google search, and I'm gonna do it in front of you guys, and we can say who is the owner of sethc.exe. Let's see what Google gives us. And owner count, maybe make it okay. Now they're asking if I am a human. Guess I'm not. It says here is trusted installer. All right. However, if we look at here, there's something before. And let's try to get that. Right? Trusted installer anti-domain, I think, like that, something like that. Oh, it's called anti-service trusted installer. So let's try that. See, anti-space service. So let's try that. And here we go. So what we leverage here is that the timestamp of the ICACLs and take on was close to when the SETHC security change event in the USN Journal happened, and this is how we know that this is the answer. Now we go further in the question 12, and in here they're asking about the threat actor renamed a previously identified folder in order to replace it. What is the new name of this file? And what is the full path of the file that replaced it? So first we have to figure out the rename event of this file. So let's try to do that. So another update reason, we have something called rename. So let's do that, rename, right? And let's look into SETHC. And here we are. So let's look at the event. We have rename old, which basically we are renaming this old to something new. And rename new is basically the new name of that file. And in this case, what we see in here, we have the same entry number, which basically means it's basically the same file that got renamed. And this is basically the new name of the file. So we got the first part, and it matches basically the first whatever hint they're giving us. Now, we're trying to check what is the full path of the file that replaced it. So since we named the sethc.exe to .back, now my question would be, what was changed to sethc.exe? Now our goal is to know what changed. And what I would like to do is that there's a methodology is to do secth.exe, and then we have here rename, and I guess we have a methodology, we call it let's try to remove a bit this rename, right? Let's remove, see what other things we have. We have something EA change, security change, right? And at what time? This is 9:20, so this is something where we're at. And you can see the sectac.back. You can see the entry number between those two. It's different, so it means it's a different file. And if it is a different file, then we have to figure out what this file is. One way to do it is we can check the entry number itself, right? We can check the entry number. And to do so, we have to go to the MFT now. Now we have to go all the way to the MFT. So we have to do this. So we have to also use the cape. So let's do it again. MFT, and we're gonna click on that, and we're gonna run it. We're gonna wait until, but basically now, my goal, the next step is to check what is this file, what is this entry, and how does it differ from this one, and only then can I know really if this actually is the same file or a different file. And then afterwards I can try to check what is this file exactly. So let's take it easy. Okay, so now it's processed. Let's open that. So it's here. If you guys want more like in-depth explanation about everything that we have done in this lab, please drop in the comment section everything that you would like me to actually, you know, like talk about, and hopefully we like make it more clear about each type of artifact, what can we find and everything. So we have here the parent entry sequence number and everything. So let's take that from here. So let's take this entry number and put it in here. And as you can see, guys, we have the sectac.back. Now let's check the other one. And we have another sectac.exe. So this is when it got the original file name that got renamed into this file name. And you can see that it got created around that time. Let me give you guys a trick. File size is such an underrated value, because usually file size it's like very difficult for you to have the same executable that have the same file size. So let's try to look for file size inside of, you know, the MFT. And here we are. Not a big surprise to me. It's basically cmd.exe in this case. And we have, in this case, we have to give the full path. And the full path would be this one. And let's put C in here. C colon, then cmd.exe. And it should work, and it did. Now, in order to gain higher privileges, the threat actor had to terminate the initial session to start a new one with elevated privileges. What timestamp mark when they gained a high privilege shell on this workstation? Now we're trying to figure out when did the user actually gain that high privilege window, right? It's important for us to understand when did he gain that. On top of my head, if I want to think about it, since we were talking, the moment he gained this higher privilege is when he executed the sethc.exe executable that basically is cmd.exe with this kind of like privilege. So I have to look in the prefetch for sethc.exe execution, and this is my first attempt to do. So I'm gonna look and I'm gonna check sethc.exe, and here we go. See, we have two entries, the 922 and 927, and basically in here we see that probably the first one, because how prefetch works, it doesn't record only one timestamp, it records up to 8. So we're gonna take the first one and we're gonna try, right? And as you can see, it was this exact attempt. Now let's continue in defense evasion. So the threat actor created a folder and executed a command to whitelist it in the primary security tool on the machine. What is the full path of this folder? So now they're trying to ask us about the whitelisted folder on a security tool. Well, as we all know, maybe you guys don't like it, but Windows Defender is a good tool in my opinion. And since, you know, like they're trying to create a lab environment, they're not going to be installing like another security tool. So my first go-to, I would want to check if Windows Defender exists on this device. And luckily in the event basically security events, or like logs, event logs of Windows, we can try to look for the you know, Microsoft Defender logs. So let's try in here the provider to be Defender. Let's try to look for Defender. We have nothing. Maybe let's try the channel instead, Defender in here, and I think we have something. And see, we have logs for Microsoft Windows Defender. Now, as we did before, we want to probably limit to a specific date, which is 21 June, and let's do that. So let's go back to April 25th, and then June, and then 21, then okay. And now we have all those logs, and we have the description. Description is very important in my opinion, because it helps you understand what is going on. And I like to do a grouping to see what is a different event that happened. So we have an anti-malware scan finished, scan scarred, Defender is up, running, and in healthy state. The anti-malware definition updated successfully. This one, the anti-malware definition, seems interesting to me. Why? Because it could mean that something has been updated. And if you want to check what was updated, let's see in here. Okay. Nothing seems of interest. All right. So let's check something else. Configuration change could be something to look into. And let's check if something can catch our eye. Wait, the new value could be interesting. So let's check. And let's look at the old value. Let's see if we can find something related to exemption. Okay, nothing related to exemption, so let's remove. And let's try to look if we can find something around the time of interest, which was around 925. Guess probably the first one. Do I find something? Okay, wait, I do find something. So we have old value empty, and the new value it's here. It's actually here, exclusion. I should have looked for exclusions. So there was no exclusion before, but now we have an actual exclusion, and the path is actually C program files 86 AnyDesk. So let's take that and give it to it. So basically, he whitelisted AnyDesk for being basically scanned by the defender. The last question is related to persistence. So it seems that the threat actor created and whitelisted a directory, then downloaded and persisted an implant there. What is the implant file name, and what description did they assign to the persistence entry? So if I want to think about it, I would first probably go to that path in the MFT and check what files existed there. So let's do that. So let's take this file path and try to check in the MFT what's going on. And do that here. Wait, what? Let's put AnyDesk. And we have 2 files in here. Let's check if there is other file in the USN Journal. Sometimes if someone deleted something, it could be basically that, you know, we have to check. And let's take the parent entry in here and go to the USN Journal. And let's put it in here. Wait, let me remove everything and then put it again. And we have multiple file create. And as you can see here, the same data basically. We have the gcapi.dll that got created. And at 9:28. And we're gonna add, let's see, so GCAPI. And we have to think about the implants file name and what description did they assign to the persistence entry. So when you think about persistent entry, you have to think about one thing. Sorry, I'm gonna reconnect. You have to think about 3 main things in Windows. You have to think about schedule task, you have to think about services, and you have to think about auto start in the registry. In this case, I wanna try to look for services, and there is a specific event ID for that. It's called, let me first ungroup in here. It's basically 7045, and basically it tracks any new service that got installed on this operating system. And we can see here on 21 we had basically 2 new, basically 4, but I'll probably look at the last 3 because of the attack started around 9. So 931 could be our potential here, and we can see here name AnyDesk. We can see Microsoft Defender and KSLD. So probably as we're looking into AnyDesk in here, and you can see auto start type. Auto start means even if you restart your computer or shut it down, when you turn it back on, it's gonna run again. And then we can see that it's trying to execute AnyDesk automatically, so it allows basically the attacker into the machine. So I'm guessing it's gonna be anydesk.exe. And then for the description, let's see if we can find it somehow. Description. Let's see, maybe in the actual here. So let's see the description to find something. I mean, there's no real description. There's only the name of the service. And that's pretty much it. Let me see. Another way to look into services, if you guys are unaware, is to actually go into the registry. I didn't want to do this. I hope like I had the information here, but it is what it is. So we're gonna go into the registry and try to look this up. And to do that, we have to go registry analysis and registry explorer. This is also another tool from Eric Zimmerman. This guy is a beast. Shout out to him. And basically now we're waiting for registry to exe. So basically we're gonna go to the system hive and we're gonna check all the services and we're gonna look into AnyDesk specifically to see if there's a description there. So we're gonna go load the system hive. In this case, it's gonna be artifacts C Windows System 32 config, and we have system in here. So we have the registry, and then we have to replay the transaction logs, and we're gonna do that. So we load both. Okay. And then we're gonna save it in here. It's gonna ask us first to if you want to load the updated, and yes, we want. We don't want to load the dirty one, so we don't. And now we have to go to the actual services to check the services, and it's gonna be in the current control set and then services in here. The good thing about Registry Explorer, it parses the things for you. So let's try to look for AnyDesk, and here we are. Actually, you have a description in here. And it's called Start AnyDesk on Startup. So let's do that. Start AnyDesk on Startup. And here we are, we finished the labs. Congratulations, guys. I'm sorry. I know like it's my first time doing this this activity. I hope guys you will be patient. And like I mentioned before, please drop in the comments anything that you think I can improve, anything that you want to learn, and I will try to tackle them as we go. Please don't forget to like and share and subscribe and turn on the notification button. Thank you guys and have a great day.